What can you say about these pictures? Special halo-halo, special lumpia, special fried rice. Please input your answer on the text box below. If your answer is, they are all special food, then you are right. Good job. Why do you think these foods are special? Yes, that's right. Because they have a unique ingredient that is not found in any other food in the same kind. Don't you know, in mathematics we also have a special topic that we called as special products. Product is an answer of multiplication. Special product, it is the quick and easy method of obtaining the product of polynomials because of some patterns and formulas. These patterns are sometimes called shortcut method of multiplying polynomials. There are four kinds of special product. We have square of binomial, sum and difference of two terms, square of trinomial, and cube of binomial. For today's lesson, we are going to discuss about square of binomial. What do you mean by binomial? Please put your answer on the text box below. Yes, you are right. A binomial is a polynomial having two terms. If you're going to square a binomial, we are going to raise the two terms into the second power. The square of binomial has the pattern of a squared plus 2ab plus b squared, where a stands for the first term and b stands for the second term. For you to understand where did you get the pattern, please watch this video.
How would you calculate the value of 109 squared? It's simple. We multiply 109 with 109 and calculate the value, right? Hang on. Before you proceed, let us take a look at the first identity. The first identity says a plus b the whole squared equals a squared plus 2ab plus b squared. This means that no matter what values we substitute for a and b, this equation will always be satisfied. The first question we should ask ourselves is how. The proof is very simple. A plus b the whole squared can also be written as a plus b multiplied by a plus b. Using the distributive property, we can write it as a multiplied by a plus b multiplied by a plus b. We can write it as a squared plus ab plus ba plus b squared. This product equals this and this product equals this. We can write ba as ab. We write this expression as a squared plus ab plus ab plus b squared. These two terms are like, and because they are like, we can add them. So we get the answer as a squared plus 2ab plus b squared. Now comes the second question. Why is this identity special? Why do we need it? Look at the example we saw before. We were asked to calculate 109 squared. We could have solved it in the traditional way by multiplying 109 with 109. But that would have taken us really long. Let's look at an interesting way to solve it. We use the identity we just learnt. We can write 109 squared as 100 plus 9 the whole squared. Now we have it in this form. We can say 100 is a and 9 is b. The first term is a squared, so here it will be 100 squared. The next term is 2ab. It will equal 2 multiplied by 100 multiplied by 9. B squared is 9 squared. 100 squared is 10,000. 2 multiplied by 100 multiplied by 9 equals 1,800. And 9 squared equals 81. So adding these numbers, we get our answer as 11,881. This identity makes us solve such problems very easily. Conventional multiplication would definitely have taken more time.
In words, the pattern states: square the first term, twice the product of the first and second term, and square the second term. Now, let's put this in an example. Example number 1. X plus 3 squared. Step 1. You need to identify the first term and the second term. So, what is the first term on the example? Okay, now our first term is x, and our second term is 3. Second step, use the pattern and substitute. The pattern is a squared plus 2ab plus b squared. So, write the given, substitute the first and the second term. 2x times 3 plus 3 squared. Then simplify. This is x squared. 2 times x times 3 is 6x plus 9. And this is now your final answer. I want you to box your final answer. Next example. 2x minus 5 squared. Again, the very first step is you identify your first and second term. Your first term is 2x. Your second term is negative 5. Next step, use the pattern and substitute. Your first term is 2x, so 2x squared plus 2x times negative 5 plus negative 5 squared. Then simplify. It will become 4x squared minus 20x plus 25. And that's it. That is easy. And don't forget to box your final answer. We are now on example number 3. X squared plus 4. What is A? Please write your answer on the text box below. What is B? Please write your answer on the text box below. If your answer for A is x squared, then you are right. And if your answer for B is 4, you are also correct. Now let's move on to the second step. Use the pattern and substitute. What is the next step? Okay. Your next step is you're going to substitute the first and the second term. So it will become x squared squared plus 2 x squared times 4 plus 4 squared. Then simplify. What do you think is the answer? Please write your answer on the text box below. If your answer is x to the 4th plus 8x squared plus 16, then very good, you are correct. And as I've said, always box your final answer. all for square of the binomial. Thank you. Until the next video. Today, we are going to discuss the second type of special product, which is sum and difference of two terms. What is sum? And what is difference? If your choice for sum is the answer for addition and difference is the answer for subtraction, then good job, you are right. You can say that the factors are sum and difference of two terms if they have the same first and last terms and opposite operations. The other one is addition and the other one is subtraction. If this is the case, then you can use the pattern, which is a squared minus b squared, where a stands for the first term and b stands for the second term. In words, you can get the product of sum and difference of two terms if you're going to square the first term. The operation in between is always minus, and square the last term. For you to fully understand this lesson, let's have an example. Example number 1. X plus 5 times x minus 5. The very first thing that you're going to do, you're going to examine the given. Do they have the same first terms? Yes. Do they have the same last terms? Absolutely yes. Are their operations opposite? Yes, because the first factor is addition and the other one is subtraction. Meaning, this problem is sum and difference of two terms. Then we can follow the simple steps. Identify the first and last term. What is the first term? What is the last term? If your answer for A is x and your answer for B is 5, then you are correct. You can now proceed to the second step. Use the pattern, then substitute. The pattern is a squared minus b squared. So, if the given is x plus 5 and x minus 5, we will just substitute x to A and 5 to B. Then simplify. It will become x squared minus 25. As easy as that. And always box your final answer. Let's have example number 2. 2m minus 4 times 2m plus 4. Again, identify the first and second term. What is your first term? What is your second term? The first term is 2m. The second term is 4. After identifying the first and the second term, then you can proceed to step 2, which is use the pattern, then substitute. The pattern is a squared minus b squared. So you will copy first the given, 2m minus 4, 2m plus 4, so that you will be guided. Then substitute 2m squared minus 4 squared. What do you think is the final answer? If your final answer is 4m squared minus 16, then very good, you're correct. And always box your final answer. Now, we are now on the third example. 3d squared plus 5 times 3d squared minus 5. Now proceed to step 1. Identify the first term and the second term. What is our first term? What is our second term? Please put your answer below. If your first term is 3d squared and your last term is 5, then good work, you're correct. Then proceed to step 2. Use the pattern, then substitute. The pattern is a plus b, a minus b equals a squared minus b squared. Then I want you to copy first the example so that you will be guided. Then substitute. Our first term is 3d squared. Squared minus 5 squared. What do you think is the final answer? Please choose your answer wisely. If your answer is 9d to the 4th minus 25, then very good, you're correct. Okay, and as always, we're going to highlight by boxing our final answer. That would be the last example for sum and difference of two terms. Thank you, and until the next video. Square of trinomial. A trinomial is a polynomial having three terms. If we're going to square a trinomial, it has the pattern of a squared plus b squared plus c squared plus 2ab plus 2ac plus 2bc, where a stands for the first term, b stands for the second term, and c stands for the third term. But how do we get that such a long pattern? So this is how do we get the pattern of square of trinomial. So if you're going to square a trinomial a, b, and c squared, it means that you're going to multiply a plus b plus c by itself. And using the distributive property of equality, you're going to distribute the terms, the first term to the second factor. Also b times a plus b plus c plus c times a plus b plus c. Then distribute a. It will become, we're going to distribute this one, it will become a squared plus ab plus ac. In the same manner with b, distribute b to a plus b plus c. So it will become ab plus b squared plus bc plus ac plus bc plus c squared. Now combine like terms. So as you can see, we will write first terms with the higher degree. So we will write first a squared plus b squared plus c squared. So we write first the terms with higher degree, then combine like terms. We're going to combine AB and AB here. So there are two AB, so it will become 2AB. Another one, we're going to combine AC and another AC here. So it will become 2AC. And lastly, we're going to combine
BC and the other BC here. So BC plus BC, that will become 2BC. And that's how do we get the pattern for square of a trinomial. It is square the first term, square the second term, square the third term, twice the product of the first and second term, twice the product of the first and the third term, and twice the product of the second and the third term. For you to understand better how to solve problems involving square of trinomial, let's have examples. Example number 1. 2x plus 3y minus 5 squared. The very first thing that you're going to do is identify your first, second, and third term. What is your A? Your A is 2x. Your B is 3y. And your C is negative 5. After identifying your first, second, and third term, then use the pattern and simplify. The pattern for square of trinomial is a squared plus b squared plus c squared plus 2ab plus 2ac plus 2bc. If you're just going to use the pattern, then there's nothing go wrong. This time, substitute a, b, c to the given. So, that would be 2x squared plus 3y squared plus negative 5 squared plus 2x times 3y plus 2x times negative 5 plus 3y and negative 5. This time, simplify. What is 2x squared? The answer is 4x squared. 3y squared, that is 9y squared. And negative 5 squared, that is positive 25. 2 times 2x times 3y, that is 12. 12xy. Next, 2 times 2 times negative 5, that is negative 20x. Lastly, 2 times 3 times negative 5, that is negative 30. Copy the variable y. And that's it. That would be our final answer. Always box your final answer. Now let's have another example. 5m minus 2n plus p squared. Okay, what did I tell you the previous video? The first thing that you're going to do is you identify your first, second, and third term. So we're going to have the first term is 5m, the second term is negative 2n, and the third term is p. And the second step, you need to write first the pattern, which is a squared plus b squared plus c squared plus 2ab plus 2ac plus 2bc. And you need to substitute the given to the pattern. So the pattern is 5m squared plus negative 2n squared plus p squared plus 2 5m times negative 2n plus 2 5m times p, and lastly 2 times negative 2n times p. And the last step is you're going to simplify. 5m squared, that is 25m squared, negative 2n squared, that is positive 4n squared, plus p squared. 2 times 5, 10, times negative 2, negative 20. Copy the variables, mn. 2 times 5 times the imaginary one here, that is positive 10 mp. And lastly, 2 times negative 2, that is negative 4 np. And that's it. That is now our final answer. We always box our final answer so that it will be emphasized. That's all for the square of trinomial. Thank you and see you in the next video. Today, we are going to continue discussing the different kinds of special product. And on this time, we're going to have the last but not the least kind of special product, the cube of the binomial. When you say cube, what does it mean? Please input your answer below. If your answer is multiplying the term 3 times by itself, then you are correct. So if we're going to cube a binomial, we're going to raise the binomial to the third power, which has the pattern of a cubed plus 3a squared b plus 3ab squared plus b cubed, where a stands for the first term and b stands for the second term. But the question is, how did we get that pattern? Okay, we will discuss how did we get the pattern in this video. We get the pattern by this long method. So if we're going to cube the binomial, it means that we're going to multiply that binomial 3 times by itself. So meaning it is equal to a plus b times a plus b times a plus b. We're going to combine these two binomials here because we already know that they multiply by itself by twice, so it means it's a plus b squared. And we are very familiar by this because we have already discussed this on the first topic, which is this one is the square of a binomial. So we already know that squaring a binomial is equals to a squared plus 2ab plus b squared. And by the distributive property of equality, we're going to distribute a and b to the second factor. So it will equal to a times a squared plus 2ab plus b squared plus b times a squared plus 2ab plus b squared. And simplify. It will become a cubed plus 2a squared b plus ab squared plus a squared b plus 2ab squared plus b cubed. Now this time, we're going to examine the given terms. We're going to combine like terms. And the like terms here are 2ab squared or 2a squared b and this one. So it will become a cube. Combine this one, 2a squared b and a squared b, then it will become 3a squared b. And another like terms is this one. We have ab squared and 2ab squared. So if we're going to combine them, it will equal to 3ab squared, and lastly copy b cubed. Then this is how did we get the pattern for the cube of a binomial. And always box your final answer. So that's how do we get the pattern for cube of a binomial. So cubing a binomial has this pattern. In words, cube the first term plus 3 times the square of the first term and the second term plus 3 times the first term and square the second term plus cube the second term. So, for you to better understand this topic, let's have examples. Example number 1. M plus 1 cube. The very first step that you're going to do, you first identify the first term and the second term. What do you think is the first term? And what do you think is the second term? Please input your answer below. If your answer for the first term is M, then you are correct. Very good. And for the second term, if your answer is 1, then you are right. Good job. Next step, you will use the pattern, then substitute. The pattern is this one. So, we're going to substitute the first and second term to the pattern. So, our first term is M. So, substitute M to A. Cube plus 3m squared times the second term, which is 1, plus 3m, the second term, which is 1 again, plus 1 cube. Then simplify. This is m cubed plus, what is m squared? So still m squared times 3 times 1, that is 3m squared plus 3m times 1 squared. 1 squared is 1 times 3, still 3m plus what is 1 cube? That is 1 times 1 times 1, and the answer is still 1. Then that's it. That is now our final answer. And what you're going to do? Yes, you will box your final answer. Okay, now let's have another example. Let's have example number 2. 5x minus 2y cubed. Again, the first thing that you're going to do is identify your first and second term. What do you think is our first term? What do you think is our second term? Please input your answer below. If your answer for the first term is 5x, and if your answer for the second term is negative 2y, then very good, you're correct. Next step is use the pattern, then substitute. The pattern is this one. Then we're going to start from this. Copy first the given so that you will be guided. 5x minus 2y cubed. Substitute. What is our first term? Yes, 5x. 5x cubed plus 3 5x squared times negative 2y plus 3 5x times negative 2y squared plus negative 2y cubed. Then, simplify further. What is 5x cubed? Meaning, this is not 15. Please be informed that the answer is not 15. 5 cubed is not 15. Meaning, you're going to multiply 5 by itself 3 times. Meaning, 5 times 5 times 5. So, what is 5 times 5 times 5? The answer is 125x cubed. Next, let's do it step by step. 3, what is 5x squared? That is 25x squared. Times negative 2y plus 3 times 5x. What is negative 2y squared? Negative 2 times negative 2. The answer is positive 4y squared. Plus negative 2 times negative 2 times negative 2. So please bear in mind that is multiplying negative 2 by itself 3 times. That is negative 2 times negative 2 times negative 2. The answer is, what is the answer? The answer is negative 8y cubed. Next, we will finalize our answer. This is 125x cubed. 3 times 25 times negative 2. What is the answer for that? 3 times 25 times negative 2. Please input your answer below. If your answer is negative 150, then you're correct. Very good. X squared y. Next, 3 times 5 times 4. What is the answer for 3 times 5 times 4? Yes, the answer is 60. 60 x y squared. Then we will remove the parenthesis for the last term. The answer is 8y cubed. Okay, now that's it. I think that is now our final answer. Then, to emphasize our final answer, we're going to box it. Don't forget to box your final answer always. Okay, good job. Now let's move on to the last example. X squared plus 2 cubed. So first, identify your first term and your second term. What is your first term? Our first term is x squared. And our second term is 2. Next, use the pattern, then substitute. Our pattern is this one. So, we're going to copy first the given so that we will be guided. We will be guided. All of us will be guided. Then, substitute x squared cubed plus 3 x squared times 2 plus 3 x squared times 2 squared plus 2 cubed. Before moving on to the next step, you examine again your equation. If there is something you forgot to put or you forgot to substitute, I think that is all correct now. Then we will proceed to the next step. Using the laws of exponent, x squared cube, what are you going to do to the exponent? Please input your answer below. Are you going to add or multiply the exponents? Yes, you're right. We're going to multiply the exponents. So it will become 2 times 3, it will become 6. Plus 3 x to the 4th squared plus 3 x squared. What is 2 squared? 2 times 2? 4, yes. Plus 2 times 2 times 2 because it's cube, meaning 2 times 2 times 2, the answer is 8. Good. Now this time we will finalize our answer. We will multiply the numerical coefficients 3 and 2. The answer is 6 x to the 4th plus 3 times 4, that is 12 x squared, and copy the last term. Oh, we are done answering. We already have now the final answer for example number 3, and our final answer is x to the 6th plus 6x to the 4th plus 12x squared plus 8. Very good. Now, that's all for the cube of a binomial. Thank you and God bless.